Hello everybody, today I'm going to discuss the solution to the second problem from the 2024 US Open contest, which is walking along a fence. And again, just like you might have seen with the previous video, I am recording this while we are still in the contest window, so that will be my solution, the way I approached it, and you might see other approaches also after the contest is over. But I want with this video to show you how to solve this problem, but not just how to solve this problem, but also how to come up with ideas to solve these problems, which are more and more difficult, as we can see during contests and in general whenever you want to solve more and more difficult problems. So let's get started. So we have n cows here, and each of the cows wants to take a walk along the fence. And we know that the fence has p posts, and we know that each of the posts lays on a position along the coordinate lines. And we know that the coordinates are quite small, so they are integers up to 1,000. And also we know that the polygon is a polygon that has sides parallel to the x and y axis, and the polygon is well behaved, so we don't have degenerate sides or anything like that. And we know that each cow has a preferred starting and ending position for her daily walk. And basically we want for each cow to find the minimum distance she will have to walk, knowing the starting and the ending positions, which are both within the polygon. So we want to see whichever path is better for the cow to take. So let's say that we have this polygon here. So let's say that I won't be drawing the polygon from the example. I will draw something else. So let's say that we have this polygon from here. I don't know. Let's see that. Let's make it a bit more complicated. Okay, so it also has to respect the condition that everything is perpendicular. So yeah, I'll just make this a bit longer. So now yeah, this point is going to be at the corner, and the other ones too. So let's say that we have these points. Now we want to be sure that we want to be able to cover all of these. And a very important thing, and a thing that you will see will help us a lot, is that the points are already given in a sorted order. So be it clockwise or counterclockwise, we don't need to deal with this anymore, as that would have made the problem quite a bit more difficult, in my opinion. Also, another very important thing that will help us is that the coordinates are up to 1,000. So this means that we will have at most 1,000,000 points we will ever need to check. So these two informations give us the idea that maybe trying something like a brute force will work. And this is quite a common technique when it comes to bronze problems, as you can often just either simulate the process or do some brute force to pre-compute and then solve the queries more efficiently. And this is something we are going to do here. So starting from the first point, we know the direction towards we need to go to the second point. So we will just mark each of the points with its relative position compared to its origin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we keep doing that, 11, 12, 13, 14, and we keep doing that, so on and so forth. So I just put these so to understand what I really mean by doing that, and we can keep going until the very end. So now for each point we know the relative position. Now, how does the relative position help us? We also know the entire length of the polygon, because we can measure the sum of the distances between each two adjacent sides. So now all we have to do is that for 2 points in a query, let's say this one and this one, don't forget that all of the points are inside the polygon, like on the edges of the polygon. We know where each of them is placed relative to each other. So now we have two options. We either go like this, so we go along this side, or we go along this other side. So we have these two options, and we can go using either of them. So we can split these paths, and we can either go like this or like that. So based on the relative positions we have, all we need to do is just to check whichever of the two paths is better to follow. And in order to do that, all we need to know is the relative position, because we can say that we are kind of like in a circle, although it's not a circle. And this will help us simplify the process, because we can determine the distance based on the relative distances. And then all we need to know is that either, let's say, the distance between them is x according to the relative distance. All I need to know is whether x is smaller than, let's say, total minus x, because if total minus x is smaller, then we can follow the other path to get it done faster. And this will be pretty much it for this problem, as it two steps that will be required are the fact that first we need to simulate and pre-compute where each point lays relative to the original point, to the first point, and then the second step is to do some simple casework based on whether it's better to go this path or this other path. So let me show you now the solution. So again, a write-up as usual. You will see this also when I post the video. I read the points. I also put the last point as being the first point, a common technique when it comes to polygons. First, we want to know in which direction we need to go with the points between one side and the next side. And now, of course, if we are done, we want to break. And we know also that the relative position of the first point is going to be 1, as it will show up twice in our computations. And now all we have to do when we look at the queries is to see if the distance between the positions is smaller or bigger than the other distance, the total minus that distance, and we just print the minimum of them. So in this problem, as a conclusion, we just need to be careful about the statement, the fact that there are not many points involved, and this will help us just rely on brute force to get this done. So if you enjoyed watching this video and if you found this solution to the problem useful and interesting, please like, subscribe to the channel, and also stay tuned to more content I'm going to post. And also check out the description more ways in which you can interact with me, including classes, courses, and other similar things. So I offer classes for USACO. They are very good, and students keep achieving higher and higher results even with these especially more difficult problems. So thanks for joining the video, thanks for watching it, and see you next time. Cheers.